This call is now being recorded. This call is now taking notes.
Okay, so welcome to the higher GCSE Maths class. So similar to yesterday's foundation class as well, we'll be going through exam questions and going over quite a lot of content. Now today is going to be a lot harder than yesterday's class, so it will be the higher grade 8, grade 9 questions, but it's better to see them now than seeing them quite later on. So we'll jump right into it. If you've got any questions, the chat is open as usual as well. Okay, so we're starting off with quadratics first. So let's go over a bit of background about quadratics. What exactly are quadratics? So quadratics. So a quadratic is something that's an equation of the form y equals ax squared plus bx plus c, where a, b, and c are numbers. So it's something x squared, something with an x and a number. She's trying to join by email, won't work. I've sent her the link by text message as well, so she can use that, Davin, or you can send her the link as well if you want to, just copy and paste it. She can take from somewhere else. Okay, she should be in now. Okay, so a quadratic is something of that form. So something x squared, an x, and a number. So it has to have an x squared minimum. Now, you need to also know what they look like. Now, these can be U-shaped graphs or they can be N-shaped graphs. So how do you know if they're U-shaped or if they're N-shaped? It depends on what A is. So if A is a positive number, then it would be a U-shaped graph. If A is a negative number, it'd be an N-shaped graph. So that's how you remember that. So let's look at a few examples. If I had y equals 3x squared plus 2x plus 5, that's a quadratic. And we know it's a U-shaped graph because this 3 is positive. That makes it U. If I had y equals minus 2x squared plus 10, again, this is a quadratic equation, but because the number with the x squared is negative, this is going to be an N-shaped graph. And you should notice as well, with the quadratic, it always, well, not always, but for GCSE, it crosses the x-axis at 2 places. So we're going to be going over factorizing and solving quadratic equations. You'll always get 2 answers for x, and the reason why you do is because it crosses 2 places on the x-axis in both cases, which you can see. And it crosses the 1 place at the y-axis. Okay, so keep these graphs in mind when we're working with quadratics. Let's jump on to some exam questions. Now, the word factorize means putting it in brackets. And the word solve means find x. So make sure you understand the difference between these 2 words as well. So factorize, putting it in brackets, solving, you're finding x. Now, these ones are a bit of tricky examples because in front of the x squared, you've got a number. Usually you don't have that number, you're finding 2 numbers at times to give you this and add to give you that. You can't really do that in this case. So there's a few different methods you can use to factorize and solve these. So I'm going to go over a few of these methods here. So I'll label what method they are as well. So when you get these notes, you can see what they are. So first of all, I'm going to factorize this using the AC method. Now it's up to you, whatever method I use, you can choose one yourself. Now, what is the AC method? The AC method says, we've just said that with a quadratic equation, that, where is it? We said this is the A term, that's B, and that's C. So we can label the quadratic. Go back here. We can label that A, this is B, and that's C. So A is 2, B is 5, and C is 2. So the AC method says we need to find AC first. AC just means A times C. So A is 2, and C is 2. So 2 times 2 is 4. Now what I need to do is I need 2 numbers at times to give me 4, but add to give me 5. So 1 times 4 gives me 4, and 1 add 4 also gives me 5. So that one works. We can use that. So we're going to start our brackets. And we've got 1 and we've got 4, which is what we're going to keep here. That's what we're going to have here. Now, usually you just put x's in the front, but in this case, we're not doing x's because there's a 2 here. So it would be 2x and it would be x. No, sorry, 2x like that. So 2x in both of them. Now, what we need to do is we need to divide the whole thing by 2 because we can simplify this. So 2x plus 1 divided by 2, I can't simplify that because I'll end up getting a fraction. When you're factorizing, you can't get fractions. So that first bracket will remain as is, 2x plus 1. The second one, 2x divided by 2 gives you x, and then 4 divided by 2 gives you 2. So that's your final answer. Now, a lot of people do not like using this method. Personally, I don't use this method either because in the exam, it can be quite stressful finding the two numbers that will fit to go here, especially if it's a big number. So there's another method I will show you how to use as well. But that's the AC method. And that's your final answer. We've just factorized it. Okay, this question here says solve 3x squared plus 17x plus 10 equals 0. So basically find where it crosses the x-axis. We are going to expect two answers. Now here, I'm going to use the quadratic formula method, so you can see that. Quadratic formula. And personally, I use this method for everything to do with quadratics, even factorizing, which I'll do an example of, because it just always works without having to think of two numbers at times to give you a number and add to give you a number. What is the quadratic formula? The quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. So all we're doing is a, b, and c, putting it straight into this formula, and you just get your answers for that. So x equals, different color. So x equals minus b. We know a is 3, b is 17, and c is 10. So minus b, which is minus 17, plus or minus b squared, which is 17 squared. Let me just get a calculator. Now, what I'd recommend with this as well is a lot of people just put everything straight into the calculator and they'll end up getting it wrong. So b squared, which is 17 squared, I'm going to put that in my calculator. That gives me 289. And then I've got minus 4 times a times c. So minus 4, I'm going to do it to the side here, times a, which is 3, times c, which is 10. Minus 4 times 3 is minus 12. Minus 12 times 10 is minus 120. So notice how I'm doing it in parts. All divided by 2a. So 2 times a, which is 2 times 3, which is 6. Let's further simplify. Minus 17 plus or minus 289 minus 120 gives me 169, and the square root of 169 is 13 divided by 6. So my two answers are going to be either I'm going to have x equals minus 17 add 13. So notice how there's two signs here. We've got add and minus. Minus 17 add 13 divided by 6. Or I've got minus 17 minus 13 divided by 6. So putting that in the calculator, I get minus 17 add 13 divided by 6 minus 2/3. I will leave that as a fraction. I wouldn't change that to a decimal because it continues forever and it's not accurate. And then minus 17 minus 13 divided by 6, it gives me minus 5. So that's your final answer. We've solved it. We've found our x values, and we expected two values because if you look back to the quadratic graph, it crosses at two places. So I'm expecting two answers. That's the reason why you get two answers with quadratics. Okay, we've got a factorized question again. This time I'm not going to use the AC method because I've shown you what the AC method is. What I'm going to do here is I'm going to use the quadratic formula method, but I'm going to show you how to use it backwards. Now, as you've seen from question 2, the quadratic formula tells you what x's are, but factorize means putting it in brackets. So let's use the quadratic formula and see how we can factorize with it. We know a equals 3, b equals minus 11, and c equals 6. There's a minus sign here. That's quite a common mistake that students make as well, forgetting that that's part of b. Quadratic formula, I'll just put it here again. Minus 4ac, all divided by 2a. So putting that in, x equals minus b. We've got minus minus 11. When you've got two minuses together, that becomes plus. Plus or minus the square root of b squared. Minus 11 squared is minus 11 times minus 11, which is 121. We've then got minus 4. I'm going to do it here. Minus 4 times a, which is 3, times c, which is 6. So minus 12 times 6, which we get minus 72. And then that's all divided by 2a, 2 times a, 2 times 3, which is 6. 11 plus or minus 121 minus 72 gives us 49, and the square root of 49 gives us 7. Divide that by 6. So finally, our two answers is x equals 11 add 7 divided by 2, which gives us 9. And x equals 11 minus 7 divided by 6, which gives us 2/3. Okay, so we've solved it for x. We've just found our x values. However, the question says factorize. So now the extra step that you would do here is think about it here. When we factorize and you end up solving this, you always end up taking the opposite signs. So for example, if you were solving this, you would say x equals minus 2. And then you would solve that as well. So you would say 2x plus 1 equals 0. So 2x equals minus 1 and x equals minus a half. A reason why is because you'd make it equal to 0. Two numbers have to, if two numbers are timesing together to equal 0, one of them has to be 0. So you take the opposite signs. So we're doing this backwards now, so just keep that in mind. So let me just get rid of that. Back to this question. So putting these into brackets, how would we do that? Well, we know for this bracket, it would be x minus 9. You would take the opposite sign. And for this one here, it would be x minus 2/3. But we're not allowed to have fractions in brackets. So we need to times this 3 up. So the answer we get here is we get 3x minus 2. And then we get x minus 9. Because this one's fine. There's no fractions there. So to get rid of that fraction, you just times the 3 up. And then that's how you factorize it. So your final answer is just 3x minus 2 and x minus 9. Okay. If you've got any questions as well as we're going along, do ask in the chat as well. Just checking. X plus 7, the answer, divided by 3 is divided by 6, sorry, is 3 for that one. So I just made a slight calculate mistake there. $18 divided by 6. Yeah, 18 divided by 6 is 3. So then that would be x minus 3. Okay, so that's how you factorize it with the quadratic formula method. You've also got AC method as well. So you can use one of them too when you're factorizing. So AC method or factorizing like that. I'll do the quadratic formula method again, just so you can see in another example. So factorize fully. So remember, factorize means putting it in brackets. A equals 6, B equals 17, and C equals 12. I've just got them from the front. Using the quadratic formula again, let me just put it down here so you can see. So x equals minus b, which is minus 17, plus or minus the square root of b squared. 17 squared is 289, minus 4 times a, which is 6, times c, which is 12. Minus 4 times 6 times 12 gives me minus 288. And then divided by 2 times 6, 2a, which is 12. Now, another way you can realize you made a mistake as well, if you end up getting a negative answer here, you can't square root a negative number. So if you end up getting an error in your calculator, most likely it's because you've ended up getting a negative number there somehow, and you shouldn't get a negative number there. So that gives us minus 17 plus or minus the square root of 1, which is just 1, divided by 12. So our two answers for x, we get minus 17 add 1 divided by 12, which gives us minus 4/3. And we get minus 17 minus 1 divided by 12, which gives us minus 3/2. Okay, so we've got two fractions there, and we can't have fractions in our brackets. Let's make our brackets and see what happens. Remember, it's the opposite sign, so we get x plus 4/3 there, because plus 4/3 is the opposite of minus 4/3. And here we get x plus 3/2, because it's the opposite. Now we can't have fractions, so we need to times these up. We're going to times the 3 up to here, so we end up getting 3x plus 4. And we're going to times the 2 up to here, so we end up getting 2x plus 3. and then that's our final answer. So it's up to you. This method, I would say, with the quadratic formula, you don't have to think as much and you don't feel that pressure in the exam because you're not finding two numbers at times and add to give you a certain number. It just works. You just plug everything into the formula. Okay, moving on to question 5. Factorize fully 2x squared minus 98. Now, this is a different method here. We can't just stick it into the quadratic formula because we don't have a b term here to do that. So what this is first you need to realize, okay, I can pull out a number, both 2 and 98 are even numbers. So I can pull out a factor of 2. There's no common letters, so I've just pulled out 2. 2 times something gives me 2x squared, that's just x squared. 2 times something gives me minus 98. Well, minus 98 divided by 2 is minus 49. So yeah, now we can still factorize it. So that's only 1 mark. This question's a 2-mark question. It says factorize fully. What you need to realize here is this is difference of 2 squares. So difference of 2 squares. Now what difference of 2 squares is? Difference means minus, and I can see there's a minus sign here. So this rule won't work if that's a plus. And we can see that there's 2 squares. So 2 squares, x squared, that's a square. And 49 is a square number as well. So make sure you know your first few square numbers. So I'll just write them here. So the square numbers. We've got, actually, I will put it on the other sheet so it's not on the exam questions. So remember your square numbers. And make sure you know your cube numbers as well. At least the first 5 will help you definitely. So 1 squared is 1. 2 squared, 2 times 2 is 4. 3 squared is 9. 4 squared is 16, 25, 36, 49, 64, 81, 100. So, and 121, 144. Your cube numbers is when you cube them. Now we're going to be talking about surds later on today as well. So this is where the square numbers will also be important. Now the cube numbers is just cubing the numbers. So 1 cubed, 1 times 1 times 1 is 1. 2 cubed is 8 because 2 times 2 is 4, and then 4 times 2 is 8. 3 cubed, 3 times 3 is 9. 9 times 3 is 27. Got 64, 125. So I'd say make sure you know at least the first 5 for definite. Okay, coming back to here. So we've recognized that they're 2 squares. Now the rule with the squares is, so let's leave the 2 there. We end up getting 2 brackets. You put a plus in one and you put a minus in one. It doesn't matter which order you put in, because multiplication is commutative. Like 2 times 3, which is 6, is the same as 3 times 2, which is 6. It doesn't matter which order you do it in. So what you do is you square root each of these terms. The square root of x squared is x, so let's put x in each of them. And the square root of 49 is 7, so we just put 7 in each of them. And that's fully factorized. So that's what it means by factorize fully. So you've got your first mark there, and then you've got your second mark there. Okay, the next thing we're going to move on to is quadratic inequalities. Now, what a quadratic inequality is, you can see here's a quadratic, and there's the inequality sign. So this is really common on a higher paper as well. Now, with these questions, I would always recommend you draw the graph. So always draw the graph, and you'll see why. So, and we already know it's just a sketch. Now, what a sketch means, it's not accurate, but you've got some ideas to what it looks like. So for example, like we know it's U-shaped if A is positive, and we know it's N-shaped if A is negative. So that's really important. So let's see. Solve x squared plus 4x plus 3 is more than 0. Now the first thing we need to figure out, we know we need to sketch the graph, but we can't sketch the graph unless we know where does it cross on the x-axis, so we can get that sketch. So we need to find out where it crosses on the x-axis by using the methods that we've just gone over above. So I'm just going to use this is quite a basic one. So I'm just going to find 2 numbers at times to give me 3 and add to give me 4. Well, that's just 3 and 1. So 3 and 1. So we've just factorized it. So therefore, we know we're just taking the opposite signs. X equals minus 3 and x equals minus 1. So it's the opposite signs because we need one of these to equal 0. Okay, so we've got our 2 x values. Now this is where it crosses on the x-axis of the graph. So we know minus 1 and minus 3 is roughly like over here. They're on that side. It's just a sketch. So I'll leave that like that. We know it's a U-shaped graph because this is positive. If that was minus x squared, it'd be an N-shaped. So there's a U-shaped graph. So let's just say it looks like that, where this is -1 and this is -3. Okay, so this is the important part now of using the graph. Let me just write that a bit better. That's -1. Okay. Now this is the part where we're going to use the graph in order to understand the inequality. Now it says solve when this equation, remember this graph here is this equation. Solve it when it's more than 0. Now this graph is more than 0 above the x-axis. Let me just this color. So above the axis is when it's more than 0. If the question said less than 0, I'm looking below the x-axis. So I need to find where is this graph above the x-axis more than 0. And I can see that this graph is more than 0 here and here, because them two sections are above the x-axis. This part here is below, so it's not that part there. Okay, so now I need an inequality that represents these two tails. Now, what you need to realize is as well, these graphs, they continue forever upwards. It continues, keeps going up. Now, I need inequalities that represent each of these values. So for this one here, I'll do it here. For this one here, I can say this graph exists for all x values more than -1. So x values more than -1. Because, say for example, if x was 10, and that is more than -1, it'll be up here somehow, so it's still true. It's so for all values of x that's more than -1, the graph is here basically. It can't be less than -1 because that's not part of the graph. Let me just get rid of that there. Okay, now we need an inequality that represents this tail here. Now this exists for all x values less than -3. So that's my inequality, less than -3. It's not more than, because more than -3 is down here. So it's not any of these values, it's all the other values. So that's my answer. My answer is x is more than -1 and x is less than -3. So that's the reason why we draw the graph, so we know which inequality to take. Okay, so it can be slightly confusing at first. You might not have seen this yet in school, but again, this is quite common on a higher paper. So definitely do know how to do this. Okay, let's solve this inequality here. Now notice only difference here. There's an equal sign there, but it's also less than 0. So we need to sketch the graph. To sketch the graph, we need to solve it. So I'll do the bracket method again. So two numbers at times to give me 12, but add to give me -7. I could say -6 -2, no, -3 -4. Yeah, so -3 times -4 is 12. And -3 add -4, that is -7. Yes, so that works. Again, if you don't like this method, you can just stick it in the quadratic formula and it'll give you the two answers. So therefore, my two places where it crosses the x-axis, take the opposite signs, x equals 3 and x equals 4. So let's sketch the graph now. So I know it's going to be, is it going to be U-shaped or is it going to be N-shaped? It's going to be U-shaped because x squared is positive. So it's a U-shaped graph. And it crosses 3 and 4, so it's on this side. So I would say it looks somewhat like this, where this is 3 and that's 4. So it's just a sketch. Let's just extend it there. Okay, so this time I want the graph where it's less than or equal to 0. So before we said more than 0 is above the x-axis. So we're looking this time below the x-axis because that's less than 0. So they're the two things you need to understand, more than 0 or less than 0. Okay, so where is the graph underneath the x-axis? Well, it's here. It's this part here. So this time it's a finite amount of values. It's all the numbers that's between 3 and 4. Before, in the last question, it was all the numbers that were in these tails here continuing forever. So it's a finite amount. To represent that finite amount, all we need to say is x is in between 4 and 3. So this is how we write it. It's just a sandwiched amount of values, so you just have one inequality. It's all these values here between x being 3 and 4. And because in the question there's an equal sign there, you have to put the equal sign underneath. In the last question, there was no equal sign, so we didn't put that in. Okay, let's do another one. Solve x squared is more than 8x plus 9. Now, the reason why I chose this example is because I wanted to show you that quadratics, you always have to make them equal to 0, no matter where you see them. If you've got something ax squared plus bx plus c, you have to make it equal to 0. If you notice in all our examples above, that equals 0. This is 0. We've got a 0 over here as well. Quadratics, they can't get solved unless you do that. Okay, let's look back at that again. So what we need to do is we need to bring everything over to the left-hand side. So we've got x squared, change the color. We've got this 8x that we don't want on the right-hand side. So the opposite of plus 8x is minus 8x. And the opposite of plus 9 is minus 9. And that's more than 0. So now this question looks like the last two questions that we did. We need to solve it so we can find where it crosses the x-axis and draw it. So two numbers at times to give me minus 9 and add to give me minus 8, minus 9 plus 1. Again, you can use quadratic formula method if you're not a fan of this one. So therefore, x equals 9, the opposite of minus 9, and x equals minus 1, the opposite of 1. So we can sketch the graph. It's a U-shaped graph because it's positive x squared. If that was negative, it would have been n-shaped. And it crosses minus 1 and 9, so it would look somewhat like this. That's minus 1, and that's 9. Just a sketch. And it is more than 0. So remember, we said more than 0 is above the x-axis if it's more than 0. Where's the graph above? It's here, and it's here. So it looks a bit like the first question. We've got two tails. So our answers would be, for this one here, it would be x would be more than 9. So for all values of x more than 9, the graph is up here because it continues forever. And this one here, it's for all x values less than minus 1 because it's all them values going backwards. X is less than minus 1. We don't have to put an equal sign underneath it because there's no equal sign in the original question. Okay, and they're the two answers to it. Okay, so that's a little bit about quadratic inequalities. Quadratics is quite a big topic. It also comes under simultaneous equations. Now, for foundation simultaneous equations, you just solve the two linear ones, meaning you get two that look of this format, and you cancel out your x's or your y's. For higher, they give you one quadratic as well, so there's a different method you need to use. Now, as long as you understand what simultaneous equations are and why you're doing a certain step, this should be quite self-explanatory. When you're solving simultaneous equations, you've got two unknowns. What do I mean by unknown? Something that we don't know. So we can see we don't know x, we don't know y. There's two unknowns, and to solve that, you need two equations. That's what simultaneous equations is. If I had three unknowns, which they won't give you in GCSE, like if I had x, y, z, I need three equations to find x, y, z. So I've got two unknowns, so that's why I've got two equations. Now, the only way you can solve them is you need to get rid of one of the letters. So that's the reason why in foundation, you cancel out one of the letters. We're going to kind of do the same thing here. So what we're going to do is we're going to substitute this into here. So the y, I'll use a highlighter instead. And the reason why we can do that is because y equals 2x minus 3. So if y equals that, I can just plug it straight into the top one, and you'll see why I do this. So I'm substituting this into the top. So I get x squared plus y squared, which is 2x minus 3 squared, and that equals 41. Now you can see clearly the reason why I've done that is now I've got an equation which just has x. There's no y's, so I can solve that. So that's our aim. Try and think if you're doing something in a simultaneous equations question, you're doing it to get rid of one of the letters, so you can just solve it like normal. So now we can solve this because there's no y's. So x squared plus, now be careful here, a really common mistake that students make. They'll just say 2x squared minus 3 squared. That's not how it works. This is 2x minus 3 times 2x minus 3. And that equals 41. So write that down just so you can see that you're timesing two brackets together. So we're expanding this bracket here and we're expecting a quadratic. Let's expand. Now, some of you might have learned the grid method in school. Some of you might just expand by just using FOIL, which is what I'm going to do. So I'm going to do 2x times 2x. I'll do it in a different color so you can see. 2x times 2x, which is 4x squared. 2x times minus 3, minus 6x. Minus 3 times 2x is minus 6x again. And minus 3 times minus 3 is plus 9. And then that equals 41. So that's how you expand using the FOIL method. I would say get used to doing that because constantly drawing grids, especially like with triple brackets and really harder things, it can get messy quite quickly. Let's collect like terms. We've got x squared plus 4x squared. So gathering them two together, we get 5x squared. Minus 6x is minus 12x. Plus 9 equals 41. Now remember what we said above, quadratics always have to equal 0 when solving them. So I can see I've got a quadratic here because I've got something x squared, something x, and a number. So it's a quadratic. So I need to make the quadratic equal to 0. I'll just write it there. That should be popping in your mind. So I need to minus the 41 to the left-hand side. 5x squared minus 12x plus 9 minus 41. I get minus 32, and that equals 0. Make sure I got that right. Yep, that's right. So now you can use one of the methods above to solve this. So I'm not going to do that now just because we've not got a lot of time in this. So you can use a quadratic formula or you can use the AC method. But the two answers that you end up with, you get x equals minus 8 over 5, and you get x equals 4. If I was to recommend a method, I would highly recommend the quadratic formula method to doing this. Okay, so we found our two x values, but what about our y values? We've not found y. So what we need to do is you need to substitute your x values that you've just found into one of the equations to find y. Now, you can use any of the equations above, these two that they've given you, to find y. But why would you use the top one? You're making it harder for yourself. You'd rather use y equals 2x minus 3 because it's just easy to solve that to find y. So let's let x equal minus 8 over 5. Plug in that here, I get y equals 2 times minus 8 over 5 minus 3. So I get y equals, for that one, minus 31 over 5. So there's your next answer. Now we've got another thing to substitute. We need to substitute this in. So let's let x equal 4. Then y equals 2 times 4, which is 8. 8 minus 3, which is 5. There's our next answer. So that's that makes sense. We've got two answers for y and we've got two answers for x. Now, just for a bit of higher level thinking as well, which you should be doing here, when you're solving simultaneous equations, well, I'll do the next question. I'll come back to what I'm going to explain. Now here it says the graphs of the straight lines with these equations. So it's just y equals mx plus c. Two equations are on the graph they've drawn. And it says use the graphs to solve these two simultaneous equations, and it's only 2 marks. So it says use the graphs. You're not meant to solve them like how you were doing foundation, like cancelling out the numbers and stuff. What the examiner wants you to do is just read this spot that's right here. Simultaneous equations basically means where your two graphs crossing. So all we're doing is we're just reading this point here, so we can see it's at x equals 2 and y equals 4. So because it says solve, I can't write the coordinates 2, 4. It says solve. Solve means what are the letters? And the letters are x equals 2 and y equals 4. So that's the reason why it's only 2 marks. If you ended up solving this algebraically, doing the method, you wouldn't have got the marks because you've not done what the questions told you. It says use the graphs. So using that idea, I just want to come back up here. You should recognize that this equation here is a straight line graph. And you should recognize here that this is equation of a circle. Now we have got an equation sheet, which Davin and Hannah's seen, and it's got all these graphs that you need to know. So you should recognize that's a graph of a circle, and that's a straight line. If you've not got that, just drop us an email and we'll send you that out. So if I've got equation of a circle, which looks, where can I do this? I'll just do it down here. So if I had a circle, I'm just going to draw it like this, and I had a straight line that just crossed through it, and I'm just going to say it's that. I can see that it crosses at two places, so therefore I've got two x values. I'm going to have an x value that's here and an x value that's here, and I've also got two y values, a y value that's here and a y value that's here. That's the reason why you get 1, 2, 3, 4 answers. So you should start making all these links to different topics. That's where the higher level thinking comes into place with what they're testing you in the exam. So yeah, that's just a bit of background information as to how they work. Okay, we've got another simultaneous equation question here. So it says the diagram shows two straight lines. They've given us the equations of both the straight lines, y equals mx plus c. It says work out the coordinates of the points where the lines intersect. So they've not told you it's a simultaneous equations question and said solve, but they want you to recognize that. Now I've got y equals 2x plus 3, and I've got y equals minus 2 over 3x plus 1. A lot of you might be tempted to make the x's the same or something and minus the equations from each other. You don't have to do that. Because each of these equal y, we can just make them equal to each other because they're both the same thing. So I can say that this equation equals this equation to solve that point there. So I can say 2x plus 3 equals minus 2/3 x plus 1. And remember, with simultaneous equation questions, we just need to have one letter, and we do have just one letter. We've got x's, no y's, that's it. So we can solve this. So how do we solve this? Well, bring all the x's to one side and bring all the numbers to one side. It's just a linear equation. I'm going to plus 2/3 x to that side, so 2. Add 2 over 3 gives me 8 over 3. X plus 3 equals 1. Okay, I'm going to bring the 3 over to the right-hand side. So the opposite of plus 3 is minus 3. So 8 over 3x equals 1 minus 3, which is minus 2. And then finally, to get x by itself, I just need to divide by 8 over 3 to get rid of that. So minus 2 divided by 8 over 3 is minus 3/4. So we found the x value of this. So we know this here is minus 3/4, which makes sense. It's in the negative part of the axis. So I was expecting a negative number. If you ended up getting a positive number there, you would have got that wrong. So we've got minus 3/4 there, but we've not finished. We need to find the y. So where does it cross there? So we're just substituting into one of the equations. It doesn't matter which one you choose. I'll just choose this one here. Y equals 2 times x, which we've just found is minus 3/4, plus 3. So y equals 2 times minus 3 over 4, which is minus 3 over 2. Add 1 gives us minus a half, which, hold on, done that wrong. So can you notice how I've noticed that's wrong? That can't be minus a half there because I'm expecting it to be positive. So let me just see where I've gone wrong. So 2 times minus 3/4, 2 times minus 3/4 gives me minus 3 over 2. And then we're adding 3. I ended up adding 1. Adding 3, that's 3 over 2. Okay, so that's 1.5. So you can see how I got the answer minus a half, and I knew that was wrong because that can't be a minus number. So I've backtracked, and you should be doing stuff like that in the exam. I'll keep it as a fraction, just keep it uniform, 3 over 2. That's not a final answer. We can't say x equals minus 3/4 and y equals 3 over 2 because the question's asked for coordinates. So you need to give it as coordinates. The coordinate is x is minus 3/4 and the y is 3 over 2. So we have to give our answer like that because that's how it's asked for it. And that's the answer for that one there. Okay, we're going to move over to 3D trigonometry now, and Pythagoras. So you did Pythagoras yesterday, but just on 2D shapes. For higher, they don't really give you questions like that. They hide it inside a 3D shape. So just quickly going over Pythagoras because you have covered that yesterday. Remember, if you've got a right angle triangle, so only for right angles, you can use Pythagoras, which is a squared plus b squared equals c squared. So that's only to find lengths. It's got nothing to do with angles. So for Pythagoras, or you've got SOHCAHTOA. And SOHCAHTOA is to find both the lengths and angles. So what I would say first is when you've got a right angle triangle, try and use Pythagoras. If you can't use Pythagoras because you're not given two lengths, then move over to SOHCAHTOA. So they're the two rules that you're going to use with right angle triangles. We're going to speak about non-right angle triangles as well. But let's jump onto this question. The diagram shows a cuboid A, B, C, D, E, F, G, H. That's just each of the corners, which you can see is labeled. Now let's put these lengths onto the diagram. So it says AB is 5. So AB is 5. So that's 5 there. So try and understand what they've told you. Also, if that's 5, then of course DC would be 5, HG would be 5, and EF would be 5. So you can start labeling other things as you read in the question as well. Okay, it says AE, which is this part here, is 6. So if that's 6, then of course this will be 6, FB. GC will be 6 and HD will be 6. I'm not going to write them on because it'll get a bit too messy, but you understand the point. Just take them off for now. So try and understand that in your mind as well. It's told us AG is 12, so A to G. Okay, so A to G, you need to visualize it. It's a diagonal going straight through. So the diagonal line that's going through is 12. So imagine you've like got a box and you've sliced it in the middle. That long length in the middle is essentially 12. And it says calculate the length of AD. Well, where's AD? AD is in the back here. I'm going to highlight it so you can see. That's what we're trying to find there. Find the length of AD and give your answer correct to 3 significant figures for 4 marks. Okay, so we're going to see what lengths we've got and what we can work with to find AD. So you'll end with 3D Trig, you'll end up sketching quite a lot more than you realize. Now, AG, if I sketch the line AG, I can then pull out GC here. So if this is AG, I'm going to do it up here, just so there's space. I would always recommend as well labeling the corners just so you don't get confused with what you've drawn. So A to G, which I've drawn here, then that's going to be G to C, which is a line coming down. Now, if I want that to be a right angle triangle, it's going back to AC. So that's the right angle triangle there. So that's what I've drawn here, basically. As you can see, I've just pulled out that triangle that's inside there. Now, what lengths do we know here? Well, we know that this here is 12 AG. And we know GC is 6 because we've been told that EA is 6, so therefore GC is 6. But we don't know what AC is. So we can work out AC using Pythagoras. So it's a lot easier to spot it like this than trying to figure it out in the shape. So let's find AC. So remember with Pythagoras, we labeled the triangle. Let me try A squared plus B squared equals C squared. So I'm going to call C is definitely 12 because it's opposite the right angle, and AB, it doesn't matter what it's here. Okay, so A squared, which I've said is 6 squared, plus B squared, which is, we don't know that, we're trying to find that, equals C squared, which is 12 squared. So B squared equals 12 squared minus 6 squared, so 144 minus 36 gives me 108. So therefore B is the square root of 108, which gives me 10.3923, continues forever. Okay, so I've got my B length here, which is AC. So what I've basically found is the length AC is that number. So try and get used to using this notation here as well. Okay, so we found AC. How's that going to help us find AD? Well, I can spot another right angle triangle on the floor of that cuboid. So I can sketch that triangle out there. So if this is AD, so AD that's in the back, and then at D here, I've got D to C, which I can see that's there. Here, so I've just drawn that part out there, AD and DC. And then joining that is AC, that diagonal that we've just found. So we've just found AC here. So this is why labeling the correct length is really important. So we know AC is 10.3923. Try not round that up too much because you'll end up getting rounding errors, because our final answer, they want it to 3 significant figures. Okay, what else do we know about this length? Well, AD, this is what I'm trying to find. That's what I'm trying to find. So I'm going to call that X, actually. I'm going to call that X because that's what the question's asked me to find, sorry. And DC, do I know the length of that? Yes, I do, because if AB is 5, then DC will also be 5. They opposite each other. So that is 5. Now, again, we can use Pythagoras because this is a right-angled triangle to find out what X is. So using Pythagoras, I'm going to label C first, which is opposite the right angle. And then this is A and B. It doesn't matter which one you call A and B. Substituting that all in, we get A squared, which is X squared. We don't know what that is. That's what we're trying to find. Plus B squared, which is 5 squared, which is 25, equals C squared. So 10.3923 squared. So X, we end up getting, when solving that, putting it over to the other side, we end up getting 9.11 to 3 significant figures, and that's my answer. So just write it here. Length AD, which is what we said is X, is 9.11. So that's how Pythagoras can be made further complicated. Okay, moving on. We've got another one here. So the diagram shows a pyramid, and the base of the pyramid is a square. Why have they told you it's a square? Because all these lengths are exactly the same. That's the reason why they've told you that. So try and understand what it's asking. Don't just jump straight into it. We know AB is 5. So if that's 5, because we know it's a square, all of them are 5. Okay, cool. The point E is 10 centimeters vertically above the base. Point E, okay, so yeah, there's point E. It's 10 centimeters vertically above the base. So what it's saying is if you draw a line down and it touches the bottom of that base, that length there is 10. That's what it's saying. And it says calculate the size of angle EAC. Okay, where is that? EAC, so E's here. There's A, and here's C. So EAC, I need to draw a line there. It wants me to find this angle here, EAC. So sometimes it's quite tricky just understanding what they're asking of you as well. So that's why you need to look at a lot of past exam questions just to see that. So EAC, that's what I'm trying to find. So again, I can see a right angle triangle right there. So let's draw that right angle triangle. Starting off with that EA, there it is. So that's E on top. That's A and that's C. So that's what I'm trying to find. I'm going to call that X because that's what I'm trying to find. Okay, what else do we know? Well, we know that E to C, sorry, that's not even C. This part here is not C. Hold on. That's not C. C is all the way here. So we need to call this something else. We need to introduce our own letter. I'll just call it M. It doesn't matter what you call it, but I'll call it M because it's just the middle. That's in the middle. So this one here, it's not C, it's M. So it's there in the middle. Okay. So again, a good reason to label just so you can spot, like, make sure you've got the right letters. Okay, so the triangle I've just drawn out, let me just explain it again. This one here is this triangle that's here. I can see that there. Let's label what we know. So we know EM, we know that's 10. They've told us that in the question is 10 centimeters vertically above the base. What else do we know? Nothing else really. We don't know EA, and we don't know the size of AM, and we don't know any other angles as well. So we don't know anything else there. But we can't find X without another length. We need another length if we want to use SOHCAHTOA. So we're going to have to try and use something else in order to find that length. And I can spot a triangle that's right here. I can see a triangle there that's going to help me find the full length of AC. And I can then divide it by 2 to find AM. So that's what I'm going to use. So another triangle now. Right angle triangle. I'll just highlight which one it is. that I'm drawing on the bottom. So it's this one here, ACD, and I'll just highlight it here as well. So ACD. What length do I know here? I know AD is 5. I know DC is 5 because it's a square on the bottom, so they're the same. So I can find out what is AC. I can find out what that is. And when I find that, then I can divide it by 2 to find out what AM is. So that's how it's going to help me. So ask all these questions to yourself when you're doing a maths question. So we can use Pythagoras here. So 5 squared plus 5 squared equals, I'll call it AC squared because it's length AC. So try and get used to that notation. Or alternatively, if you want to use Pythagoras, you can say C squared as well. So it's up to you what you want to call it, but just stay uniform. 5 squared at 5 squared, 25 at 25, which is 50. So AC squared equals 50. So AC is the square root of 50, which is, I will keep it to a few decimal places, 7.07106. Continues forever, but I'll just keep it to that much there. Okay, so we know what AC is, all of that, but we need AM for this, so I need to divide it by 2. So for AM, I need to get AC and divide it by 2. So AM equals that number divided by 2, which gives me 3.5355. I'll give it to that much decimal places. So we know this on the bottom now is 3.5355. So now that we found that, we can now use SOHCAHTOA to find out angle X because we've got 2 lengths now. We're not using Pythagoras to find the angle because, as we've said before, Pythagoras is only to find lengths, so we have to use SOHCAHTOA. Okay, going back to here. So using SOHCAHTOA, again, you should have covered this in yesterday's class. How do we find X? Well, first things first, with SOHCAHTOA, you have to label the triangle. Let's label the triangle. Our hypotenuse is always going to be opposite the right angle, so that's hypotenuse. This is our angle X, so this is adjacent next to X, and this one's opposite X. So it matters where you label all them. So I know that I've got O, and I've also got A, and the one that's got O and A is tan. So we're using tan there. So tan of our angle, which we don't know, we've called it X because that's what we're trying to find, is opposite, which is 10, over adjacent, which is 3.5355. And remember, to find X, because it's inside the tan, we have to do the inverse tan when you're finding angles. So we're doing tan to the -1 of 10 over 3.5355. And the answer we get for that, because they've not said to how many decimal places or 3 significant figures, you always should do 1 decimal place. So at 1 decimal place, I get 70.5 degrees. That's my final answer. Is it a sensible answer? It is, because it's like an acute angle, less than 90. So 70.5 seems like a reasonable answer. So that's another format question with 3D, Trig, and Pythagoras. So Pythagoras and SOHCAHTOA, most likely they will ask you in this format, not in the straightforward format, like they do for foundation kids. Okay, so we've dealt with right angle triangles. What about non-right angle triangles? So with right angle triangles, I'll just write this here. Right angled triangle. You use Pythagoras and SOHCAHTOA. Also, if you're finding the area of this as well, let's say that was 2 and that was 3. To find the area, you do 2 times 3, which is 6, divided by 2, which gives you 3 centimeters squared. So that's how you find the area with right angle triangles as well. Now, it's completely different with non-right angle triangles. So non-right angled triangles. So again, this comes up in the higher paper. Foundation kids don't learn about this. There's a few different rules that you need to know for this. So there's cosine rule, there is sine rule, and there's also area of a non-right angle triangle, which is a different formula as well. So the formulas for each of these, so for cosine rule, it's a squared equals b squared plus c squared minus 2bc cos a. Sine rule, there's a few different versions of it, but I'll just write it like this. I'm going to do exam questions on these as well to figure them out. So an area equals half AB sine C. So yeah, there's three completely different things with non-right angle triangles. And again, in the exam, they won't tell you which one you need to use. You need to be able to figure that out yourself as well. So we'll go over some examples. And we'll have a further look as well at each of these equations as well. So first things first, with all these non-right angle triangle questions is you need to know how to label the triangle. So just like with Pythagoras, you're labeling ABC. With SOHCAHTOA, you label OHA. Here, we're labeling small ABC and capital ABC. Now, the capital letters, these are angles, and the lowercase letters are lengths. So make sure you do not mix them up. Whenever you've got a sine or cos anywhere, you can never stick a length next to it. All these have to be angles, the capital letters. Same case for SOHCAHTOA as well. With the sine, cos, and tan, you would not put a length there, you would put an angle. So let's get a generic triangle. Okay, here's my, it's terrible, 2 seconds. Okay, there's my non-right angle triangle. Now we're going to have three angles, which we can see here. And the angles have to be capital letters. So I'm going to say that's A, B, C. Now the lengths are the ones that are corresponding the angles. So what I mean by that, if this is capital A, then this one here is lowercase a. That's length A. If this is capital B, this here will be lowercase b. And if this is capital C, then that will be lowercase c. So that's how you label the triangle. The lengths are always opposite the angles that you've labeled. So let's do an example. So we'll do this one here. Okay, so we've got a non-right angle triangle and it's saying work out the length of BC. So BC is here. And give your answer to three significant figures. Now, you can't use SOHCAHTOA, you can't use Pythagoras because it's a non-right angle triangle. So what we're going to do is we're going to label the triangle first. So I'm going to call this capital A. And you'll see why, and that's lowercase a. I've got no other angles, so I'm just going to say that's B and C. Now here I'm going to use a cosine rule, and you'll see as you keep practicing using these rules, you'll see why. It's quite hard to just explain like immediately why we're using the cosine rule, why we're not using the sine rule. But when you see a few examples, it'll hopefully start to make sense. So what's the cosine rule? A squared equals B squared plus C squared minus 2BC cos A. Okay, now if you look at this equation closely, we can see we don't have angle B and angle C in this equation. We've only got angle A. And you can see we've got all three lengths in this equation. We've got A, B, C. So we've got no other angles. So that's the reason why whenever you're using the cosine rule, label the angle that you're using first. So I've labeled angle A first. So if that's angle A, opposite is angle, length A, and the other ones are just B and C. It doesn't matter which one's B or C in this case. Now we're just plugging everything straight into this equation. We've got A squared. I don't know what A is. That's what I'm trying to find. That's my answer. So A squared equals B squared, which I've said is 5 squared, plus C squared, which is 7 squared, minus 2BC, so 2 times 5. 2 times 5 times 7, which is 70, so minus 70, cos of our angle, which is cos 42. So A squared, putting that in the calculator, 5 squared plus 7 squared minus 70 times cos 42, I get 21.979. It continues forever. That's not my final answer. That's A squared. I want A. So I have to square root my answer. The opposite of squaring is square root. So square rooting my answer to three significant figures, I get 4.69. And that's my final answer. Okay, the next example, I'm going to come back to this one. This is just a trickier version, how they mix algebra and cosine rule together, but I'll come back to this because it's going to mix quadratics into it as well. I just want to show you the sine rule. That's here. Okay, let's see the sine rule in action so you can then see how do I know when to use sine rule or cosine rule. So here it's saying work out the size of angle x. So you can see I've got two lengths and I've got two angles. And first of all, it's not a right angle triangle, so I cannot use Pythagoras or SOHCAHTOA. Okay, I can't use cosine rule because in the cosine rule above, as you can see, there's three lengths in the equation A, B, C. This question here that we're looking at has only two lengths, and we don't care about that length because we're not finding this length, we're finding the size of the angle. So because the cosine rule only has one angle in as well, but we've got two angles here, that's how I know it's the sine rule. Now, knowing which rule to use just comes with experience and practice. So the more questions you do, the better you'll be able to spot when to use what. But here we're using the sine rule. Now, there's two versions of the sine rule. Let me go back to here. This rule here, this version, you notice that the angle is on the top, the capital letters. So we use this version here to find angles. It just makes it a lot easier in terms of just rearranging. So we use it, the angle, when the angle's on the numerator, we use that equation to find angles. Now the other version of the sine rule is just opposite way around. So A over sine A equals length B over sine of angle B over length C over sine of angle C. This version here, I'm sure you should have guessed it, the lengths are on the numerator, so we use this version to find lengths. Now, in the case that we've got the exam question, we're finding angle, so we're going to use angle version of the equation. Now, most likely, you're just going to use two parts of the equation. Notice how there's three parts there. Usually, you just end up using just two parts. The rule's just telling you that all of it's equal to each other, but we just tend to use two parts when figuring out something. So let's write that down. Sine of angle A over length A equals sine of angle B over length B. So let's now substitute label our triangle, sorry. So let's say that's angle A. So if that's angle A, then opposite, which is this, is length A. And I'm going to label this angle B. If that's angle B, then this has to be length B. Now let's just plug everything straight into the equation. So we've got sine of A, which we've said is 60, over length A, which is 15, equals sine of angle B, which I don't know, so that's X, over length B, which is 10. So we need to find X. So let's get X by itself. We've got that divide by 10 here, which I don't want. The opposite of dividing by 10 is timesing by 10. I'm going to times it up. So sine 60 over 15 times 10 equals sine of X. So I can switch them two around as well. So I can just say sine X equals this. So if I plug that in my calculator, I get root 3 over 3. I've not found X yet though. You should recognize this from SOHCAHTOA. To find X, you have to do the inverse of sine to pull it out. So sine to the -1 of what you've just found, root 3 over 3. And then to three significant figures, the answer that you get is 35.3 degrees to three significant figures. That's my final answer. Okay, let's go back up to the other one now. So I just want to show you what happens when they can mix certain topics together. So I've shown you a cosine rule example. I've shown you a sine rule example. It'll come with experience knowing which rule to use, but most likely these are what have been coming up in the past exam papers. So they mix quadratics with trigonometry, but the harder version. So here it's just saying work out the value of X. So let's do this here. Now we can see we've got a non-right angled triangle. So it's going to be cosine rule, sine rule. And we can see that we've got three lengths. and we've got one angle. So 3 lengths and one angle, which rule is that? It's not sine rule, it's cosine rule. So the cosine rule, a squared equals b squared plus c squared minus 2bc cos a. We can see one angle, there's no other angles, and we've only got one angle here. And we can see 1, 2, 3 lengths, ABC is in it as well. So that's why we're using cosine rule. So all we need to do is label the triangle, plug everything straight into this, and we're going to end up solving to find x. So quite a tricky question, 5 marker. Let's plug everything in after labeling. So this is our angle A. We always label our angle A first. So this is length A. This is our B and C. Remember, it doesn't matter which one you call B or C in the cosine rule equation, because B squared as C squared is the same as C squared plus B squared. Okay, a bit like with Pythagoras, how it doesn't matter as well. Okay, B, C. Now we're just putting everything in. So A squared, which is, let me change the color, root 73 squared. So there's going to be a lot of algebra testing in this question as well. We've got B squared, which is 2x minus 3 squared, plus C squared, which is x plus 2 squared, minus 2 times B, which is 2x minus 3, times C, which is x plus 2, times cos of 60. So just to reiterate what we've done, we're using the cosine rule, we've labeled the triangle, we've put everything into that equation. And the only difference compared to the last example is we don't have numbers, we've got letters, we're doing algebra in this. Okay, so now let's slowly simplify and collect like terms. Root 73 squared, well, if you're doing root 73 times root 73, the square root just cancels. So we get 73. 2x minus 3 all squared is, remember, 2x minus 3 times 2x minus 3, just like we did in the first example with quadratics. Plus x plus 2 times x plus 2, that's for here. Then we've got minus, okay, so I'm going to do this in parts. First, what is cos 60? Cos 60, putting that in the calculator, is a half. So we know this here is a half. And I've got a half times 2. So I'm working out all this, simplifying all this together. A half times 2 is just 1. So I don't really need to write a 1 here because I've got these that I'm dealing with here. So I'm just left with minus 2x minus 3 times x plus 2. Because 2 times a half gives me 1, I don't really need to write a 1 there. A bit redundant to write that down. You can write it down there if it helps you with your working out, but you don't really need that 1 that's there. Okay, so now we're expanding. So hopefully we'll have space for this. I don't think we will, but 73 equals 2x times 2x, 4x squared, 2x times minus 3, minus 6x, minus 6x, and then plus 9. So I've expanded this here to here. Expanding the next one, just going to do this one quickly. Okay, and now this one here is really important because there's a minus sign here that affects it. So put your minus sign, that's on the outside, but when you expand, keep everything in brackets because that minus is going to affect everything. So we've got 2x times x, which is 2x squared. We've got 2x times 2, which is 4x, minus 3 times x is minus 3x, minus 3 times 2 is minus 6. So it is a lot of work, but it's the same thing. So it looks a bit scary, but it's the same thing. We're just collecting like terms, solving a quadratic. 73 equals, let's collect all our x squareds. We've got 4x squared, add x squared, and not plus 2x squared. Remember that minus is affecting it. So minus 2x squared. So we get 4, 5, so 5 minus 2, 3x squared. Okay, so we've dealt with our x squareds there. Now let's do our x's. So we've got minus 6x, I'll do it in a different color. Minus 6x, so that's minus 12x. I'm just keeping my calculator. Plus 2, so plus 2 again. And then we've got not plus 4x, remember it's minus 4. That minus is affecting it because there's a bracket there. So minus 4. And then we've got minus 3, which is plus 3. There's all the x's, so that's minus 9x. I've just put that all into my calculator. Now let's do the numbers. We've got, do a different color. We've got 9, add 4, minus 6, which is add 6, and that gives us minus 54. Now, what you should notice here, remember what we said before, quadratics always have to equal to 0. So we need to get this 73 over to the right-hand side. And I know I've got a quadratic because I've got something x squared, something x, and a number. So 3x squared minus 9x. And then if I minus 73, so minus 54, sorry, this here should be 19. Let me double check. 9, add 4, 13, and then minus 6, which adds 6, yeah, 19. So 19 minus 73, because I'm minusing 73 to make it equal to 0, minus 54 equals 0. So look how we got that really big equation to something just small that you should recognize just as a normal quadratic. Find x. Now you can solve this however you want. You can use the quadratic formula. You can use AC method, but I've just noticed something. All of them go into the 3 times tables, 3, 9, and 54. So I can divide the whole equation by 3. So I get x squared minus 3x minus 24, yeah, minus 18 equals 0. So I can make the equation even more simpler. So I can factorize that. 2 numbers at times to give me minus 18 and add to give me minus 3, or you can use the quadratic formula method if you want. We get x minus 6 and x minus 3. So therefore, our 2 answers to x, we get x equals 6, or we get x equals, sorry, minus 6 minus 3, that's 18, but we've got minus 18. So that has to be a plus. Minus 6 times 3 is minus 18. Minus 6 is minus 3, yeah. Okay, so we get x equals 6, or we get x equals minus 3. Remember, we take the opposite sign. Now, we can't have 2 answers for x. It's a triangle we've got. So how can there be 2 answers? Now, what you need to think is triangle length has to be positive. So therefore, I'm going to reject the negative answer because it's a triangle, and length. So I'm going to reject because length is positive. So my final answer is x equals 6. That's my final answer. So that's just to show you how it can get complicated by introducing algebra and trigonometry and mixing topics together, which is quite a common thing to do in higher papers as well. So what you need to be faced with. Okay, we've got area of a triangle here. So it's a non-right angle triangle, so I can't just do 10 times 9 divided by 2. I have to use area equation. So area equals half AB sine C. So which I've just shown you before over here. Area of a non-right angle triangle is half AB sine C. So let's label the triangle. Remember, capital letters is angles. So we've got C, which is angle here. So we label that C. And then these are AB. Because it's not, remember, length C is always opposite C. Length C is not in this equation. We've only got AB. So it doesn't matter which one you call AB. I'll just say that's A and that's B. Now we just need to substitute everything in. So area equals half times A, which is 10, times B, which is 9, times sine C, which is sine 30. So area to 1 decimal place, you get, I'll put that in the calculator, 0.5 times 10 times 9 times sine 30. We get 22.5. So a nice straightforward one. It's just a matter of fact of knowing that you need to use half AB sine C for that. Okay, let's move over to Surds for the last 15 minutes. I don't think we'll be able to finish this. There's been quite a lot of hard questions in this, but we'll do Surds. Now, what is a Surd? If we go back up here and we look at our square numbers, if we square root any of these square numbers, so let's say, for example, I square root 4, I get 2. You get plus or minus 2, but we'll just say you get 2. You get an integer. Remember, integer is a whole number. The answer to this one, the answer to that one was 22.5. Davin? 22.5 meters squared. You just plug everything right in. I'll send all these out after as well. Okay, so let's do another one. If I square root 81, I get 9. So, which is a square number. So if I square root any square number, I get a nice integer whole number. However, if I square root something that's not here, not a square number, so for example, root 3, this is a surd because it's not listed here, it's in between here. And if you put root 3 in your calculator and you change it to a decimal, it's, I don't know if you can see that, but it's a number that basically, you can put it in yourself, it's a number that continues forever. It doesn't stop. We call that an irrational number. So you can't really do maths with them as decimals, so we leave them as surds, and there's quite a few surd rules you need to know if you're doing higher. So looking at this, write root 50 in the form k root 2. So we know what a surd is now. The purpose of surds is you try and keep them as surds just because they can get messy quite quickly. So, okay, this one here. So surds, a rule is I can break this down. I can say two numbers that times to give me 50. And they've given me a clue in the question. They said 2. So something times 2 gives me 50. Well, I know 25 times 2 gives me 50. And the surd rule says I can split that into 2 surds like that. So root 25 and root 2. And we know 25 is a square number. We've had it listed there. 25 is a square number. Square root of 25 is 5. So I can say that's 5. But root 2 is a surd. 2 is not a square number. So we leave it like that. So we've just got it in the form k root 2, where k is 5. So 5 root 2. So sometimes the question does help you with that 2 being there. Okay, we've got a different one here. It says write 7 root 20 in the form k root 5. Now ignore that that 7's there. Let's deal with that root 20. So I'll keep 7 there. Now root 20, I need it to times by something that's 5 because there's a 5 there in the question. So something times 5 gives me 20. Well, that's 4. And then splitting it up just like last time, we could say that's 7 root 4 root 5. Now we know 4 is a square number, so the square root of 4 is just 2. We've got 7 times 2 times root 5. Remember me writing these all together, there's an imaginary time sign there. It's a bit like with algebra. When you write letters and numbers together, same with surds. So we've got 7 times 2, which is 14, and then we've got root 5. Can't do anything with that because that's a surd. Our answer is 14 root 5. So I would say there's a lot of overlapping rules with algebra rules and surd rules. So use them over here, like seeing 3 things together, they're timesing by each other if there's no sign between them. Okay, this is an interesting one. So write 3 plus root 5 squared in this form here, where a and b are integers. Remember, integers just means whole numbers. Okay, so 3 plus root 5 squared, a bit again like algebra, that's the same as 3 plus root 5 times 3 plus root 5, and we're going to do FOIL on this. So we're going to do 3 times 3, which gives us 9. 3 times root 5 is just 3 root 5. Remember, root 5 is a surd. Root 5 times 3 again is 3 root 5, and root 5 times root 5 is just 5. The surd cancels out, and I'll just prove that to you. If I had root 5 times root 5, working backwards, like here we split it like that, we can say that's the same as 5 times 5 under 1 square root. And 5 times 5 is just 25, so the square root of 25 is 5. So you could see they just cancel out with each other. So that's just to prove to you why they cancel out. So if you times 2 surds together that are the same, the surd just cancels out. So collecting like terms now there. 9 add 5 is 14, plus 3 root 5 add 3 root 5. Remember, we can only add surds together if the surds are the same. So it's a bit like, again, with algebra, you can't add x's and y's, you can only add x's together. Same with surds. I can't do 3 root 5 add 3 root 4 because the root's different. So the roots have to be the same. So 3 root 5 add 3 root 5 is 6 root 5 plus, oh no, we've already simplified the 5. So yeah, that's my answer. Where a and b are integers, so a here is 14 because that's a number by itself, and b is 6, and we've already got the root 5. So our answer is 14 plus 6 root 5. Okay, rationalize the denominator. Now, what rationalize means is get rid of the surd, basically. So get rid of the surd. Now, what you need to remember in maths is we don't like surds in the denominators, but we don't mind them in the numerator. That's fine. So here, we need to get rid of it in the denominator. So the rule is we just times, remember how we said up here? If you times the surd by the same surd, the surd cancels out. That's what we do in rationalizing. So the surd I've got on the bottom is root x. So I have to times the bottom by root x to get rid of it. But whatever I times the denominator by, I have to times the numerator by. So this is where your fraction rules come into. So try and make all these links to different topics. So x times root x, well, that's just x root x. And then root x times root x, well, we've said if we do two surds timesing together, the surds just cancel out. So we just get x on the bottom. Now we know with fractions, if you've got something on the top and the bottom, you just cancel it out. I cancel them out. So my final answer is just root x. You've just rationalized the denominator. There's no surd in the denominator now. There's nothing like that. Okay, moving on. Not too sure if you've seen surds in school yet, but that's kind of the basic rule with surds. We do not like them in the denominator. So here it says simplify. So notice how in this question, the reason why I picked this one out is the question doesn't say rationalize, but the question does mean rationalize. When you get a surd question that says simplify, it still means rationalize. It means get rid of that surd that's on the bottom. So to get rid of that root 3, I need to times the bottom by root 3 to get rid of that root 3. So that means I also need to times the top by root 3. So whatever you do to the bottom, you do to the top, as you do with fractions. So for the top, I'm going to write it out here. I've got 3 plus root 6 times root 3 for the top. And then I've got root 3 times root 3 on the bottom. So this is, again, just like with algebra. You do 3 times root 3, which is 3 root 3. And then root 3 times root 6, which I can't really combine that together. So I'll just write it like this for now. Over root 3 times root 3, we know they cancel. Okay, let's see if I can somehow simplify this on top. Well, I can't really, because root 6 is not a square number. So I'm just trying to figure out how we could potentially simplify that. Let's gather them together first. So I've got 3 root 3 plus root 3 times root 6. Remember, this here is 3 times 6 all under one third. 3 times 6 is 18, so we get root 18 over 3. And I can't really simplify that, to be honest. You could potentially pull out another 3 from here. So for example, because I want to cancel this 3 out with both of these. I can cancel it here, but I can't cancel it on the second one. So so this is where your questioning comes into it. I need a number times by, not 3, sorry. To pull out 3 as a number, you need to square root 9. So the square root of 9 gives me 3 to be able to cancel it out with this. So what do I times by 9 to get 18? I get times it by 2. So this is where this is why surds is a higher topic, because you need to start questioning yourself, like, what would I do to cancel out something? And then root 9 times 2, I can write like this. And I know the square root of 9 is 3. And root 2 is just a surd. So I get 3 root 2 over 3. And now I can cancel all these 3's out. So that's the reason why I did it. So my final answer is just root 3 add root 2. So a bit of a tricky one, because you have to kind of ask yourself some questions there as well. So yeah. Okay, so another tricky one. Now, sometimes in rationalizing denominators, we don't just get given a single term, we get given a few terms. So the rule's slightly different. It says show that this can be written as this. So again, they've not told you to rationalize, but whenever there's a surd in the denominator, they just expect you to know that you should rationalize. Now with this, a bit trickier. I'm going to put brackets around it and you'll see why. In order to get rid of that surd on the bottom, I'm not just going to times by √3. It doesn't work like that. What you do is you're going to times by the exact same thing, but you're going to change the middle sign. So √3 is there. Instead of it being plus, it's going to be minus. And remember, whatever you do to the bottom, you have to do to the top. So I'm also timesing the top by the same. And you'll see why we do this. The surds are going to cancel out. So remember, you take whatever's on the bottom, you just change the sign. Now, if I'm timesing them together, I can just put them together like this. Yeah, I'm just timesing two brackets together in a fraction like that, right? So we're doing FOIL. So I'll do this a little bit fast just because of time. 3√3 times 3 is 9√3. 3√3 times minus √3. Well, positive times a negative is negative. I'm going to do this up here. 3√3 times √3. I know these two are going to cancel out that surd. I end up with 3. So then these two together give me 3. And then 3 times 3 is just 9. Timesing them two together. 3 times 3 again is 9 here. And then we've got 3 times minus √3 is minus 3√3. Again, just like algebra rules as well, FOIL. Then on the bottom, we've got 3 times 3, which is 9. 3 times minus √3 is minus 3√3. √3 times 3 is plus 3√3. And then we've got plus times a negative, which is negative. √3 times √3, the surd cancels out, and it's just 3. Now let's simplify and see what happens. Hopefully, there's no surd on the bottom. So 9√3 minus 3√3. Well, on the top, we just get 6√3 for them two. And then 9 plus 9, minus 9 plus 9, that's 0, that's gone. Over 9 minus 3, which is 6. And then minus 3√3 plus 3√3. Well, minus 3 add 3 is 0. So they cancel out as well. So we've got no surd on the bottom. Now we can see with this, the 6's cancel out with top and bottom. So we're left with just √3, just like the question said. So these questions are quite good where they give you the question, the answer in the question as well. Now I'm just wary of time. I know we've only got 2 minutes left. I did think about doing probability and proportions. So it's up to you. If you guys want to stay like an extra 10 minutes, I can do these questions or potentially 15 minutes, or should we wrap it up there? It's up to you guys. But the next two topics are a bit tricky as well. So do you want to wrap it up there, or should we continue for another 15 minutes? You just drop it in the chat. Sorry if I was on mute there. So I know that was quite a tricky class, but these are the higher level, like grade 8, grade 9 questions. So I'll stop it there. We've done surds, we've done quadratics, we've done trigonometry. So there was quite a lot of tricky things there, but I'd rather you see it now rather than up close to the exam, so you're quite aware of what the difficult topics are that do come up. So I'll see you all next week for the biology session, and hope you found that one useful, and I'll get everything sent out to you. Okay, thank you for joining.